everyone. Welcome to my YouTube channel Chemistry Quest. This is our second class on polymers. In this video, we will be discussing completely about addition polymerization, its mechanism of production, along with some examples. There are three main key points of addition polymers. First is the molecule of the same manner or different monomers add together on a large scale to form a polymer. That is why its name is called as addition polymer. Second thing is monomers are of the type which are having double bond or triple bonds. Example is alkenes, alkynes and their derivatives. Free radical governed addition or chain growth polymerization is most common method. This we have already seen in the previous video. This is the recapitulation of the previous video. Now we have to study about the mechanism of this addition polymerization. So the mechanism of addition polymerization basically has three steps, and you should remember this I, P, and T. So I for initiation, P for propagation, T for termination. So first thing is initiation. We have to initiate the chain. Okay. For initiation, we should have a catalyst and an initiator. So initiator is benzoyl peroxide, or you can take acetate peroxide, or you can take tertiary butyl peroxide. As you can see in this example, C6H5CO, this double bond OO is the peroxide linkage. So in presence of free radical initiator, this peroxide linkage gets homolytically cleaved, so it is forming C6H5 radical with CH2 double bond CH2 ethene molecule, and this is a phenyl radical is formed. This is the process of chain initiation. So we can see polymerization of ethene to polythene consists of heating or exposing to lighter mixture of ethene with a small amount of benzoyl peroxide, that is initiator. The process starts with the addition of phenyl free radical formed by the peroxide to the ethene double bond, thus generating a new and larger free radical, that is chain initiation step. So we have to initiate the chain. What happens is this benzoyl peroxide undergoes homolytic cleavage and forms this particular radical, and from this CO2 molecule is removed and this phenyl molecule is formed. This phenyl molecule reacts with the ethene molecule in the reaction mixture and forms this radical. Now, next is the propagation step. So, what is the propagation step? So, what happened? This radical, what we have found in the previous step, this radical reacts with the ethene molecule and it form a bigger radical. And in the same way, again, this radical reacts with another radical, so it forms a big radical chain. Now it is continuing. Like if you have put A plus A plus A, three monomers, you will be getting three monomers joined by two covalent bonds. So this is the propagating step. How much you have put the monomer, that will decide how long the chain polymerization will take place. This is the second step. Now what we have to study about the chain termination. Now somewhere we have to stop the reaction. So at some stage, the product radical thus formed reacts with another radical. This radical which is formed, it also reacts with another radical. So what happens actually, the bond any present in between two atoms, or it could be same atoms, it shares two electrons. So as this is a radical, this is having one electron, and this is also a radical, this is also having one electron. So one electron and one electron, it completely forms a bond. So basically this forms a polythene. This is the process of addition polymerization. So, or its other name is chain growth, because it is increasing the chain of the polymer. This is about the steps of the addition polymerization reaction. Now we have to study about some important addition polymers, as we have already seen polythene in the previous video. that how it is formed is CH2 double bond CH2 under some conditions of temperature and pressure. This double bond will convert to a single bond and CH2 and here if you put here N means number of moles. If you are taking 5 CH2 double bond CH2 you will get 5 numbers here in the polymeric chain. So polythene is basically a linear, it could be a linear chain or it has a slightly branched structure. And we all know that these polymers are capable of repeatedly softening on heating and hardening on cooling, and that's why they are known as thermoplastic polymers. This is very important. What is thermoplastic? We have already seen in the last video. So thermoplastic, the peculiarity is that they soft on heating and hardens on cooling. This is about the thermoplastic polymer. Polythenes are of two types, high density polythene and low density polythene. First, we will study about the low density polythene. So in low density polythene, we have to remember some points like first is the pressure. Pressure. The pressure is very high, 1000 to 2000 atmospheres. Second is temperature. Temperature is also very high, 350 Kelvin to 570 Kelvin. And here third is the dioxygen, dioxygen or peroxide is the initiator. Peroxide initiator that it will initiate the reaction. The low density polythene is obtained through the free radical addition and the hydrogen abstraction, and it has highly branched structure. These polymers have chain structure with some branches, like they will be having some structures like this. Chains are there and with some branches. This is about the low density polythene. And low density polythene is chemically inert and tough, but it is flexible and poor conductor of electricity. Electricity, you cannot conduct electricity through this low density polythene. And next, it is very useful in the insulation of electricity wires and manufacture of squeeze bottles, toys, and flexible pipes. This is all about the low density polythene. Next, we have to study about the high density polythene. High density polythene, what is special about this is the actual reverse of the low density polythene. So first is the temperature. As the temperature is very low, example 333 Kelvin to 343 Kelvin. This is the temperature. Pressure is also low here. Pressure is also low, 6 to 7 atms. And the catalyst name is very important. That is Ziegler-Natta catalyst. Here the name is already written by me. Ziegler-Natta catalyst. It is a common name, but the IUPAC name is triethyl aluminium and titanium tetrachloride. It is basically a coordination compound that we will study in the coordination chapter. But we should remember the name. That is triethyl aluminium and titanium tetrachloride. This is Ziegler-Natta catalyst. So these are the conditions of the high density polythene and in presence of hydrocarbon solvent. So in high density polythene, what happens is the linear chains, they are present and it has high density because of close packing. Because if there is no branching, so it leads to close packing of the molecule. And what is more special is high density polythene also, they are very chemically inert and more tough and hard. They are more tough and hard. And it is used for manufacturing buckets, dustbins, bottles, and pipes, etc. So this is about high density polythene and low density polythene. I hope you are getting the understanding of the chapter. Next, we will study about the other examples of addition polymers. So other example, we have the Teflon. This Teflon forms a coating of our non-stick items, utensils which we use in our homes. So Teflon is basically it is manufactured by heating tetrafluoroethene. tetrafluoroethene with a free radical or persulfate catalyst at high pressure. You have to remember all this. This is very important. It is chemically inert and resistant to attack by corrosive agents. It is used in making oil seals and gaskets and also used for non-stick surface utensils. So, how this tetrafluoroethene is formed, what happens is this is a C double bond, C double bond. This H, this H, this H, this H. This is ethene molecule. When this all hydrogens they are removed by fluorine atom, it forms this tetrafluoroethene. Under some conditions of catalyst and high pressure, it forms the Teflon. The double bond will be converted into single bond. This is about the polytetrafluoroethane. Next, we have to study about the polyacrylonitrile. We can say in short form is PAM. Polyacrylonitrile. This is a short form. The addition polymerization of acrylonitrile. This compound, you have to remember this. CH2 double bond CH CN. CN is the nitrile group, and we have to remember this name. This is acrylonitrile undergoes polymerization in presence of peroxide catalyst to form the polyacrylonitrile. So the double bond gets open up and CN is as it is attached. So this is about the polyacrylonitrile, right? This video completes everything about the addition polymers. I hope this video would have added value to your preparation of boards, NEET as well as CUT exam. If you like this video, hit the like button. Please share with your friends and subscribe the channel and hit the bell for upcoming notification. Thank you.